Welcome to another science exploration. Today we're going to explore about the Earth's orbit around the Sun. We will explore what makes the Earth revolving without falling off. We will explore the role of gravity and motion, and in the end, look at some interesting facts about the Sun and Earth.
So why doesn't Earth just fall right into the sun? It's a massive cosmic mystery. I mean, have you ever looked up at the sky and wondered, if the sun has this incredibly strong pull, why aren't we crashing straight into it? It's constantly pulling on us. But instead of getting pulled into the fire, we perfectly follow this huge, curved path around it, which we call an orbit.
Let's look at the gravity balance. To understand how we stay so safe in our orbit, we have to look at two invisible forces playing a giant game of tug-of-war. You've got the mighty sun continuously pulling us inward and the Earth moving forward. Think of it kind of like swinging a ball tied to a string around your head. In space, gravity acts exactly like that invisible string. It keeps pulling the ball inward, but the ball's forward motion keeps it flying around in a circle. If you let go, whoosh, the ball flies away. Without gravity, Earth would just fly off into deep space. But without motion, we'd fall right into the sun. Put them together, and gravity plus motion gives us this absolutely amazing cosmic dance.
So what actually is gravity?
Let's break down what this invisible string really is and why the sun happens to have so much of it. The basic rule here is that gravity is a force that pulls objects toward each other. But here is the real secret. The larger and heavier an object is, the stronger its gravity becomes. And our sun is literally mind-bogglingly huge. It's about 109 times wider than Earth. To put that into perspective, if the sun were a giant hollow jar, you could fit 1.3 million Earths inside it. Because it is so unimaginably massive and heavy, its inward pull is just super strong.
So it's really all about how these forces stack up against each other. The sun is massive, so it has the absolute strongest gravity in our neighborhood, easily powerful enough to boss around all the planets in our solar system. Earth, on the other hand, is tiny in comparison, so our gravity is much weaker. But hey, it's still strong enough to do some really crucial jobs, right? It holds us under the ground, keeps satellites in orbit, and pulls on our moon. Actually, the moon's gravity is even weaker than ours, but it still manages to pull on our oceans and create the tides you see at the beach.
Now let's talk about Earth in motion. We know the sun is pulling us. So if we aren't getting pulled into a fiery doom, our forward motion has to be absolutely incredible. Just how fast are we moving? 107,000 kilometers per hour. I know, no way, right? That is mind-blowing sideways speed. Because we are moving forward so incredibly fast, it perfectly balances out the sun's gravity. Instead of falling straight down, we just continuously fall around the sun. It creates this endless, perfectly balanced curve.
And that brings us perfectly to the two different ways our planet is moving right now. First up, rotation. Earth spins on its own axis from west to east once every 24 hours. When your side faces the sun, boom, it's daytime. When it rotates away, it's nighttime. Second, we have revolution. This is Earth's massive journey all the way around the sun, taking 365.25 days to complete one full orbit. That creates our year. And you know that extra 0.25 day? That is exactly why we add an extra day to our calendars every 4 years for leap year. Makes sense, right?
So why do we have seasons?
If revolution gives us our year, how does it change our weather? Well, the secret is a very special angle. As Earth travels around the sun, it doesn't sit perfectly straight up and down. Its axis is actually slightly tilted. Because of this tilt, different parts of the world get completely different amounts of sunlight throughout the year. When your part of the Earth is leaning toward the sun, you get lots of warm light. Hello, summer. When it tilts away, things cool down for winter. This one slight tilt gives us our whole cycle of spring, summer, autumn, and winter.
Let's uncover some secrets of the sun.
Now that we've got our orbital dance down, let's fire off some mind-boggling facts about the incredible star right at the center of it all. 150 million. That is the average distance in kilometers from the Earth to the sun. It's such an enormous gap that scientists just call it one astronomical unit, or AU. But get this, even though it's incredibly far away, light travels so ridiculously fast that sunshine only takes about 8 minutes and 20 seconds to race all the way across space and hit our planet.
4.6 billion. That is the sun's age in years. Scientists think it formed about 4.6 billion years ago, which makes our magnificent star absolutely ancient and just a tiny bit older than the Earth itself. 15 million. This one is all about extreme heat. The surface of the sun is already a scorching 5,500 degrees Celsius. But the core,
The core is an astonishing 15 million degrees. That is where immense amounts of energy are being created every single second.
So, what is exactly inside the sun making all this heat? Well, it's mostly just two gases, hydrogen and helium, but it's structured in these fascinating layers. You've got the core, the radiative zone, the convective zone, the photosphere, the chromosphere, and the outermost corona. The real magic, though, happens right in that core. Through a process called nuclear fusion, hydrogen atoms actually smash and combine together. That's what produces the enormous amounts of heat and light that keep everything on our planet alive.
And because the sun is so massive and full of all that gas, its invisible string of gravity reaches incredibly far out into deep space. It controls the planets, their moons, asteroids, and comets, literally stretching past distant Pluto all the way into a dark, icy region at the very edge of our solar system called the Oort cloud.
So there you have it, the whole giant cosmic dance. We've seen how the sun's massive pull perfectly balances Earth's 107,000 km/h speed. It keeps us safely falling around the sun in a stable orbit. Our rotation gives us day and night, and our revolution gives us years and seasons. The sun truly is an incredible star, providing everything we need for life. Next time you look up at the sky, just think, what other giant cosmic dances are happening out there in the unexplored universe right now? If you find the video informative, please like the video. Thanks.